Hello students, we are going to understand the types of redox reaction. So there are four types of redox reaction: combination, decomposition, displacement and disproportionation. So let's understand. So we take example for combination, say when magnesium combines with nitrogen. So magnesium and nitrogen, they form what? Magnesium nitride. What is formed? Magnesium nitride. Right, now magnesium is in free state with 0 oxidation number. Nitrogen in free state is 0 oxidation number. When it combines, then magnesium is having +2 oxidation state and nitride is having -3 oxidation state. So what is happening? 0 to plus. Magnesium is changing from 0 to +2. So there is increase in positive charge. Increase in positive charge means there is loss of electron, and loss of electron is what? Oxidation. Okay, now 0 to -3. So nitrogen to NO3 is what? Increase in negative charge, or there is decrease in positive charge, or you can say there is gain of electron, and therefore this is what? This is reduction. Okay, so this reaction is combination reaction because two elements are combining to form one molecule. Okay, so this is a combination reaction and is an example of a redox reaction because it is having, or it is showing, oxidation as well as reduction. Next, let's take up the example of decomposition. So if we take water, right, now water decomposes into hydrogen and oxygen. Okay, over here hydrogen has +1 charge and oxygen has -2 charge, right, and hydrogen in free state is 0, oxygen in free state is 0. So if you look at hydrogen to hydrogen, right, free, so +1 to 0, that means we are moving in which direction? We are moving in, decrease in positive charge. So decrease in positive charge is what? Reduction. Now let's understand, right? I'll show you through the charge scale. If this is the charge scale, 0 minus plus. Now here this is +1 and we are moving to 0. So plus to 0, we are moving in this direction. So when we move in left direction, then it is known as, when we are moving from right to left, it is always known as reduction, and this takes place by gaining of electrons. Okay, now over here minus to 0. So what is happening? We are moving minus to 0. We are moving in right direction. We are moving from left to right. So there is what? Increase in positive charge, or you can say there is minus to 0. We are moving towards positive charge. So there is loss of electron and therefore it is happening. So this reaction is oxidation. Hence decomposition is a redox reaction. Is this clear? Now let's understand the example of displacement. Okay, if I take, let me take another page. So we take up the reaction displacement redox reaction. Okay, suppose we take, say, magnesium combines with H2SO4. So what will you get? You will get MgSO4 plus hydrogen. This acid is dilute. Okay, over here this is in free state, hydrogen is in +1 state, and sulfate we take as a whole as 2 minus. Okay, again over here sulfate we take as a whole as 2 minus, magnesium +2 and hydrogen in 0 state. Now what is happening? Look here, 0 to plus. There is increase in positive charge, so this is oxidation. Now here sulfate remains the same, so we will not consider. Let's see hydrogen, this is plus and now it is from plus, it is moving to 0. So that means there is gain of electron, or you can say this is reduction. So this is the third type of reaction, which is a redox reaction. Okay, next we move on to the fourth type of reaction, which is known as disproportionation. Okay, that means if there are two elements, one of the element changes its proportion. Okay, let's take example of hydrogen peroxide. Okay, say this decomposes into water and oxygen. Okay, so over here hydrogen has got one positive charge, and in peroxide, whenever, children remember, there is a linkage between oxygen and oxygen single bond, in that case oxygen is always having -1 charge. Okay, so over here this is +1, here it is -2 and 0. Now look here what is happening. Hydrogen is same, right? +1 and +2. Look here, +1 and +1 both the sides. Oxygen, look here, is -1. Okay, and from here -1 it is changing to -2, and from -1 it is changing to 0. So what is happening? Only one atom of an element is changing its state. So this is known as disproportionation redox reaction. Now this is a redox. Try to understand, if we take the scale, okay, charge scale, this is 0, this side is plus, this is minus. Whenever we move in this direction, it is oxidation, which takes place because of loss of electrons, and when we move in left direction, then it is always reduction, and it takes place because of gain of electron. Okay, so now look here, -1 to -2, so that means over here -1 to -2, we are moving in which direction? We are moving in left direction. So this is what? Reduction. Okay, now look here, this is -1 and we are moving to 0. -1 to 0, -1 to 0, so we are moving in this direction. This is what? Oxidation, right? So this is a redox disproportionation reaction. Okay, now can we consider this as decomposition reaction? No, we cannot consider this as decomposition reaction, because in this case only one element is undergoing oxidation as well as reduction. Is this clear? So therefore this cannot be a part of decomposition reaction. Is this clear? So practice these reactions, and I'm sure you're going to enjoy these reactions. Thank you.